This is your third type of distance problem, and it's actually not a distance problem as much as it is talking about motion, but it's still based on distance equals rate times time. It's a wind, current, motion problem, and there are a couple things that are different about these than the others, so you have to be really careful. Copy this stuff down. Once you're done, hit play and we'll go over it. So these problems are going to be based on a current that's moving in a river or a stream or something like that, or a wind, something that has to do with possibly an airplane flying or something like that. Just, you need to memorize before your test, and most of you will probably know a downstream. Downstream is going to push you faster, it's going to add to your rate, where upstream is going to pull against you, it's going to subtract from your rate. And if you've ever swam in a current, you know that feeling there. A wind, you're going to have to memorize these because we're not typically using these words. But a wind, when you have a headwind, it means it's blowing toward the head of the plane, typically, the front of the plane. So it's going to go against you, it's going to slow down or subtract. Tailwind pushes, it's from the tail forward, so it's pushing the plane, it's speeding it up or adding to its rate, it's helping it move faster. Here's the main difference. On the wind and current ones, because you're dealing with a wind or a current, not just a difference in your distance or your time, you are going to be adjusting both rates. The rate of the boat or plane or whatever you're talking about is going to be being added to when it's being pushed faster, and it's going to be subtracted from when it's slowing down. So it's not just one or the other like you did in the last two motion problems. Copy example 1 down, and when you're ready, hit play and we'll go through it. Because we're talking about distance, rates, and times, we're still using that same formula. Distance equals rate times time. So you set up your chart, and then you start looking for valuable information. So we know that we have a Millennium Falcon flying, and we know that it's going to have a tailwind, which helps it, and a headwind, which is going to go against it. So instead of calling it the Millennium Falcon in here, you're just going to call it with the wind that it has, so it helps you to know what to do. So this is when it had a tailwind, which, remember, this helps, pushes you forward, or it goes with you. Then when it returned, a headwind, which is against, so it's going to take away from the speed. The other word we use a lot here is with, so you might want to put that there. Now you're just going to look for information you can fill in. So does it give you anything about the distance? Look through there. The only thing I see about distance is that it flew somewhere and then it returned. So what I do know is that it went from one place, stopped there, and then went back, which means my distance is the same each time. Now I'm going to look for my rate. These are where you have to be careful. All I know is the rate of the wind, but I don't know the plane's rate in still air. That's what I'm looking for. But I do know that the rate is going to be increased here and decreased here. And then they did give me my time, and you have to be careful, make sure you fill in the time in the right spot. So when it's helping it, I'm going to travel faster. When it's slowing it down, I'm going to travel slower. So when it's helping, I made it in 5 hours. When it's going against, I made it in 5.5 hours. You always have to fill those into the correct spot. Now let's look at the one that's a little more confusing. I know I have whatever my plane is going plus the wind, whatever my plane is going subtracting the wind. So it's actually not that bad, but you need to have parentheses because you're going to have to distribute. So I have my rate of the plane plus the 25 miles or kilometers per hour. And then here, when I'm going against it, I have the rate of the plane in still air, but it's being taken away by 25 miles per hour. And that's what you're going to do every time. So let's make a couple notes here. R is the rate of the plane in still air. That's what you're looking for. You're looking for R. Okay, remind yourself here, you must have R plus whatever it is and R subtracting whatever it is every time. It's not 25 plus R and 25 minus R. It's that exact format every time. Now let's go ahead and solve this. So your tailwind ends up being distance equals rate plus 25 times 5. And once you distribute that, you end up with distance equals 5r plus 125. Okay, all I did was distribute my 5 here. So there's my first equation. Now my headwind distance equals my rate subtracting 25 times 5.5. So you might want to use a calculator for this one. And once I distribute that, I get distance equals 5.5 r minus, because I'm subtracting, 137.5. There are my two equations, and if you notice distance equals this distance here, you have an isolated variable. So you're going to go ahead, and I'll rewrite these here. Some of you might have room, but I don't, so I'm just going to go to the next page. Distance equals 5r plus 125 is my first equation. Distance equals 5.5r subtracting 137.5 is my second equation. I have an isolated variable here or the other one, so I can plug it in there for substitution. Here's my equation with my one variable, and now I'm going to solve. So I'm going to go ahead and subtract 5r from both sides. It's like a 5.0r. I end up with 125 equals 0.5r subtracting 137.5. Then I'm going to add 137.5 to both sides. Line up your decimals correctly. Use your calculators correctly. I end up with 262.5 equals 0.5r. You could do a decimal buster, but you've got your calculators also. Divide both sides by 0.5. And once you do that, you end up with 525 equals r. If you go back to your chart, you found the rate of the plane in still air, because if you added 25 miles an hour, you would find the rate it took on the way out there, and if you subtracted 25 from this, you would find the actual rate of the plane with the wind on the way back. This is the rate of the plane without any wind at all, and that's what they asked you to find. So then you would answer, the plane flew 525 kilometers per hour in still air. So if there had been no wind, it would have gone 525 miles an hour, but since there was wind, it was either sped up by 25 or slowed down by 25. You're going to set these up exactly the same way when there's a current. The only difference is you're going to fill in upstream and downstream, and then everything else is exactly the same. So I'm only showing one example because I want you to really focus on this one example, and then we'll just practice them in class. That's the end of your third set of distance problem notes.